In this video, we are going to talk about Rolle's theorem and the mean value theorem. Okay, so first of all, let us talk about the statement of the Rolle's theorem. Okay, let f of x is a continuous function on an interval closed interval a b and differentiable on the open interval a b. Okay, if fa equals to fb, then there exists at least one number c in ab so that f prime of c equals to 0. What does it say is, suppose a function is continuous in the closed interval ab, means between a and b there is no break, okay, and differentiable on open interval ab, meaning the function must be smooth. It is not like sharp corner or cusp, those kind of behavior between a and b. We are not talking about the boundary, just between a and b. If the height of the function at a and b, if the height of the function at the boundary are equal, then what it says is there must be at least one number c between a and b such that the derivative at c is 0. That means the slope is 0, right? That means the slope of the tangent is 0. So can you find out the points where between a and b where the slope of the tangent is 0? Yes, there are, right? Because it satisfies the Rolle's theorem. Rolle's theorem says that fx is continuous. This function is continuous. This is fx. This is continuous between a and b together with a and b, right? And also differentiable between a and b in the open interval, and the height of the function at a and b. These are the three conditions that the Rolle's theorem need, okay? And the height of the function at a and b are equal. Then there must be at least one. There may be more than one, but at least one point c between a and b such that the derivative is equals to 0 at that point c is equals to 0. That means the slope of the tangent equals 0. Yes, there are 3 points actually. At this point the slope is parallel to x-axis. At this point the slope is parallel to x-axis as well, and at this point the slope is parallel to x-axis. You see that? Also you see that you can find at least one critical points. That's what it is saying, right? But the critical points is expanded to not defined as well, and this is also works here. So let's see that the function is continuous between a and b including the boundary, and differentiable between a and b, and if the height of the function at the boundary are equal, then you will get at least one point between a and b. There are 3 points, right? At least one point. Let's denote that as c1, c2 and c3, right? Those are the 3 points. C1, c2 and 3 are 3 points where the slope of the tangent is parallel. Okay, let us look at this example. Is function continuous between a and b? Yes. Okay, continuous. Yes. Is the function differentiable? No. The function is not differentiable at this point. Why? Because there is a sharp corner, right? So here, continuous. Yes. Right? Differentiable. Yes. fa equals to fb. The height of the function at the boundary equal? Yes. Then we are able to find out at least one point where the slope of the tangent is parallel to x-axis. Here, continuous, yes. Differentiable, no. How about fa equals to fb? It is also yes, right? So it does not satisfy all 3 conditions of the Rolle's theorem. So we cannot find out. Here, we are not able to find out a point where the slope is parallel to x-axis. So this is the critical point. C is the critical point. But the slope of the tangent, so f does not exist. So we are not able to find out a point C where the slope of the tangent is parallel, but we are able to find out the critical point. So critical point exists here, but the slope of the tangent is not parallel to the x-axis because the tangent or the slope or the derivative here does not exist. At this point the derivative does not exist. Okay, all right, let us do some of the examples, then it will be clear. So that fa equals to fb. What is a? This is a, this is b for this function. Can we apply Rolle's theorem? We will see. Okay, so let's do that. So what is f at -1? That is fa. Let's plug in that. You can write that will be 2 and then minus -1 to the 2/3 and then that whole exponent cubed, right? So what do you get? You can get this is 2 minus, you can write -1 squared times 1/3, right? Because that is -1 to the 2/3 can be written as 2 times 1/3 and then the whole to the cube, right? So what is -1 squared is basically +1, right? So what do you get? So 2 minus, you will get root under 2 minus, so this is basically 1 to the third is 2 minus 1 is 1 to the third, right? 1 to the, so it is basically 1 to the third and then root, right? So basically root 1, which is 1. So how about here? So this implies 2 minus 1 to the 2/3 is basically 1. So 2 minus 1 is 1 to the 3. It's 1. So it is basically again 1. So FA equals to FB is verified. Now we want to show, can we apply the Rolle's theorem? So we want to see whether it is continuous in the interval and differentiable in the interval. Continuity is obvious because this function is defined everywhere, right? For between -1 and 1, it is defined everywhere. There is no x in the denominator, right? And for any value between -1 and 1, you can write x to the square and then 1/3, so that will make it positive, right? So it is basically, it is continuous, okay? Now the thing is it differentiable at all points between -1 and 1? Let's find out f prime of x. Okay, so basically let's write on fx first. Fx can be written as 2 minus x to the 2/3 to the 3/2, right? So how do you find out the derivative of this? This is like a u to the 3/2. So what is the derivative? This implies f prime of x is equals to n u n minus 1, right, times n u n minus 1, right, times u prime. What is u prime? U prime is the derivative of u, right? So derivative of 2 is 0. So times negative the derivative of x to the 2/3 is 2/3 x to the 2/3 minus 1. So if you simplify this, what do you get? Basically you can cancel these two because 3/2 times 2/3 is 1, right? So that negative will come to the front. So you can write f prime of x is equals to, I would write 3 minus x to the 2/3 to the 1/2, because 3/2 minus 1 is 1/2, times, what do you get? Oh, that negative, I want to write this negative sign to the front. And what do you write here? X to the 2/3 minus 1 is -1/3, right? So you can put that on the bottom, x to the positive 1/3. So is this function, is this f prime of x exist all the points between -1 and 1? No. Why? Because at x equals to 0. So let me write down that at x equals to 0, which falls between -1 and 1, right? F prime of x is not defined, right? So Rolle's theorem is not applicable, right? This is what you do. So to check whether the Rolle's theorem is applicable or not, what three things you need is, we check the differentiability, we check the continuity, and we check the height at the endpoints, okay? Let's do another example. Find x-intercepts of fx equals to x times root under x plus 5, and apply Rolle's theorem to find out c between those x-intercepts such that f prime of c equals to 0. So again the similar idea. So what is given? F of x, let me use different color. So f of x is given as x and then root under x plus 5, right? How do you find out the x-intercept? To find out the x-intercept, we set y equals to 0, right? So we do, this implies 0 equals to x root under x plus 5. So you solve x equals to 0 and x plus 5 equals to 0. What are the x-intercepts? X-intercepts are x equals to 0 and -5. So you want to use the Rolle's theorem in the interval -5 and 0. You see that? This is the interval. What it says, apply Rolle's theorem to find out C between those two x-intercepts. So we are applying the Rolle's theorem in this interval, okay? So to apply the Rolle's theorem, what we do? We check the three conditions. You see that? So we check the three conditions. So let us check that. So first condition is the function fx is continuous. Continuous on the interval -5, 0? The answer is yes, right? Why? Because there is no x in the denominator, so the function is defined everywhere, right? So the function is defined everywhere. That gives you value or positive value under the root. So looks like the domain is -5 through infinity, right? Because if x is -6, -7 like that, you will get negative number under the root. So -5 through infinity is the domain. So the function is continuous. If you draw the graph of this function, you will see that the function is continuous right to -5, including -5 and right. Okay, that's how the domain look like. Domain is like -5 is here, and everything right of that is the domain. So the function is continuous. Is the function differentiable? We will check that. Okay, let's find out the derivative. So so the answer for this is yes, right? Let's find out f prime. How do you find out f prime? You think that this is like f times g. You will find out the derivative by product rule, right? So so what is the product rule? It is f prime times g. F prime is 1 times root under x plus 5 plus f times g prime. What is the derivative of root under x plus 5? It's like x plus 5 to the 1/2, right? This is like a u. So u to the 1/2. So it will be, how do you write the derivative of that? It will be 1/2 u is x plus 5 to the 1/2 minus 1 times the derivative of u. Derivative of x plus 5 is just 1. So if you simplify that, you will get root under x plus 5, okay? And then plus x over 2 root under x plus 5. This is what you will get. You see that? So because when you simplify this, you will get x plus 5 to the 1/2 minus 1 will be -1/2. Since it will have a negative exponent, I'll move this to the denominator, right? So what is left is x is left on the top, and in the bottom there will be 2 times root under x plus 5. Now there is 1 in the denominator, right? How do I combine these two? So you will get like this. You will get basically 2x plus 5 root under, right? And then you so it is just like a cross multiplication. You see that? So it will be root x plus 5 times 2 root x plus 5 will be 2, and then x plus 5, and then plus x times 1 is just x, right? What do you get? 2x plus 10, right? So you will get 2x plus 10, and then plus x will be 3x plus. So you will get 3x plus 10 divided by. So basically you will get f prime of x equals to 3x plus 10 divided by 2 root under x plus 5. Is this differentiable in the open interval? Yes, because at -5 it does not exist, but anything right to -5 exists. So but we will be looking only in the interval. What interval you will be looking? The open interval. You will be looking at the interval. So you can write f is differentiable in the open interval -5, 0. That's the Rolle's theorem second statement. How about the third statement of the Rolle's theorem? You need fa equals to fb. What is f of -5? If you plug in f at x equals -5 here, you will get -5 times -5 plus 5 is 0, right? 0. And how about f at 0? F at 0 is also 0. So it applies the Rolle's theorem. So we can apply the Rolle's theorem because it satisfies all the conditions. So by Rolle's theorem, you get f prime is equals to 0, right? You will get a point where the derivative is 0. So if you do that, you will do the numerator of that equals to 0, right? So what you get is that implies 3x plus 10 equals to 0. Because when you set, let me show you that. If you set that that equals to 0, that thing equals to 0, then you multiply both sides by that 2 root under x plus 5. If you do that, that will cancel with 2 root under x plus 5 and then times 2 root under x plus 5, right? So that will cancel out. That will cancel out. So what you will get is 3x plus 10 equals to 0. That's what you will get. That's what I got here. If you subtract 10, let's subtract 10. Subtract 10, you will get 3x equals to negative 10. So what is x? You divide by 3. You will get x equals to negative 10 third. So that is basically C value, okay? So C is negative 10 third, you got. So this is the point that C equals negative 10 third lies between negative 5 and 0 as well, right? So this is the value that we were looking for. Let us do one more example here. Determine if the Rolle's theorem can be applied for fx equals to that on the interval negative 1, 3. Okay. So how do I do that again? So you need to check all those three things, right? So number one is if is fx continuous on negative 1, 3. What do you think? Fx is continuous everywhere except at negative 2, right? Because see, at negative 2, this will be basically 0, right? So something over 0 will be infinity. So it is not continuous at that point, but everywhere else, this will be continuous. So the answer is yes. We are looking between negative 1 and 3. Negative 2 lies outside that. So we don't have to worry. So we are looking only in that interval. So it is continuous. How about the differentiable? Let's find out f prime to check the differentiability. So this is like f over g. You see that? F over g. What is the formula for the derivative of the by quotient rule? What do you think? It is f prime is 2x minus 2, right? The derivative of the top times g is x plus 2 minus f is x square minus 2x minus 3. Okay, and then x square minus 2x minus 3 divided by x plus 2 square. Why did I miss that g prime? Because f prime g prime is 1, right? Because the derivative of x plus 2 is 1. So I didn't write that one. So if I simplify, what do I get? I need to FOIL this one. So what do you get here? It is 2x times x is 2x square plus 4x minus 2x will be plus 2x minus 4, and there will be negative x square plus 2x plus 3 over x plus 2 square. You see that? Now if you simplify, what do you get? 2x square minus x square is x square, right? And then plus 2x is plus 4x minus negative 4 plus 3 is negative 1. This is what I get over x plus 2 square. So is this function differentiable? I mean, if the derivative exists, yes, the derivative exists everywhere in this interval except, but this derivative does not exist at x equals negative 2, and x equals negative 2 lies outside this interval. So f is differentiable on the open interval negative 1 and 3. We don't even worry about the closed interval. We just look at the open interval. Also, tell me whether fa equals to fb. What is fa? Fa will be f at negative 1. What do you get f at negative 1? Let me plug in negative 1 for x here. Negative 1 square is positive 1 minus 2 times negative 1 will be positive 2, right? Because 1 plus 2 is 3 and then minus 3 is 0 divided by negative 1 plus 2 is positive 1. So 0 over 1 is 0. F at negative 1 is 0. And f at 3, let me plug in 3 here. 3 square is 9. Minus 2 times 3 is 6. 9 minus 6 is 3. Minus 3 is 0 over 3 plus 2 is 5. 0 over 5 is also 0. So let me list the thing what we just did. So we showed that f is continuous on the interval closed interval negative 1, 3. Also we showed f is differentiable at negative 1, 3 in the interval negative 1, 3. And we showed that the height of the function at negative 1 and 3 at the boundaries are equal. So we can apply the Rolle's theorem, right? So by Rolle's theorem, there exists a point, at least a point C, at least a number C in the interval AB, between A and B, where f prime of C equals to 0. So what is f f prime of x. F prime of x is basically x square, right? And then plus 4x minus 1. Square plus 4x minus 1 over x plus 2 square. That was f prime of x, right? But we need to do f prime of c equals to 0. I mean, you can do f prime of x equals 0. You'll get the same thing. But just wanted to stick with that. So what is f prime of c? Then it will be c square plus 4c minus 1 divided by x plus 2 square equals to 0. How do I solve this for c? I need to multiply both sides by x plus 2 square, right? X plus 2 square times x plus 2 square. If I do that, what do I get? You cancel this with that one, and this becomes 0, right? So basically you will get c square plus 4c minus 1 equals to 0. Now you want to use the quadratic formula for that. What is c equals to negative b, right? Plus minus b square is 16 minus 4ac is negative 1 divided by 2 times 1. How much is that? Negative 4 plus minus root under 16, and negative 4 times 1 is negative 4 times 1 is negative 1 is positive 4, right? So 16 plus 4 is 20 divided by 2. You see that? So I want to split the denominator. I will get negative 4 over 2 plus minus. What is root under 20? You can write root under 20 as like 4. Root under 20 can be written. Root under 20 can be written as 4 times the 5, right? But what is 4? 4 will be, root 4 will be 2. So 2 can be written outside. So what? How does it look like then? 2 root 5 over 2. Because that 4 root 4, under the root there is 4 times 5. 4 is 2. So I can write root 4 is 2. I can write that outside. And then 5 is still inside, right? Now what I am doing is I am cancelling those out. That 2 and 2. And 4 divided by 2 is 2. So what is left is negative 2 plus minus root under 5. But we are looking only in that interval, right? Only in that interval. So which value lies in that interval? If you take negative sign, you will get negative 2 minus root 5 will be bigger than negative 4. Or smaller than negative 4 because it has negative sign. So only the plus sign lies. If you take plus sign here, that will fall between negative 1 and 3. So the final answer is c equals to negative 2 plus root under 5, because the negative sign will produce a number that is outside this interval. Okay, so let us do the last example on the Rolle's theorem. Determine if we can apply Rolle's theorem for this problem. So fx is 5 cosine pi x. So what are the things we check? We check the continuity, right? The first thing we do is fx is continuous in the interval 0 to 2, and also on the boundary, right? Because it is on the closed interval. Why? Because the cosine and sine functions are continuous everywhere. That's the reason. How about the derivative? Let's find out the f prime. F prime of x is equals to, it is like 5 cosine u. You see that? It is like u. If it was just a cosine x, the derivative will be negative sine x. Since there is 5, and then if there was just 5 cosine x, the derivative will be negative 5 sine x. But there is pi times x. So it will be 5 times negative cosine u is pi x times the derivative of u, the u prime is pi. So you get negative 5 pi cosine pi x. So this is also exist everywhere, right? So the differentiability also true. How about the height of the function at the endpoints? What is f at 0? Is 5 times cosine pi times 0 will be cosine 0. Cosine 0 is 1. So it is 5. And how about f at 2? F at 2 will be 5 cosine 2 pi. Cosine 2 pi is also 0, right? So 5 times cosine 0. Oh, sorry, cosine 2 pi. Cosine 2 pi will be 1. Okay? So 5 times 1 is also 5. So f0 equals to f of 2. So it satisfies all the conditions of Rolle's theorem. Hence, by Rolle's theorem, there is at least one C in the interval 0 to 2 such that f prime of C is equals to 0. So we need to plug in C on the f prime of x, right? So how do you do that? So you do, this is the f prime, right? So negative 5 pi and then cosine pi times C equals to 0. Let us divide both sides by negative 5 pi. So what do you get? You get cosine pi C equals to 0. So what value of cosine give you 0? What angle of cosine give you 0? So you write pi times C equals to, one is pi over 2, the other is 3 pi over 2. We'll have to divide by pi though. We'll have to divide by pi, so that's fine. Okay. So there are other values too. So what is C then? C will be divided by pi. It will be 1/2 divided by pi, 3/2, and there may be other, but that will be, sorry, 3/2, not 3 over pi. 3/2, right? And then there may be other values, but that will be outside this interval. So what are the values of C? These are the values of C that lies inside this interval where the slope is parallel to the x-axis. Okay. So these are some of the examples. So basically these problems, all the Rolle's theorem and the mean value theorem are in section 3.2. So the next thing I am going in the next video will be still in the section 3.2, but that is the mean value theorem. Okay.